In this class, we're going to look at the operating principles of the AP. Implementing the plus AP that receives two numbers and adds two more values. Let's create a plus BizUnit on no-code school app. In the previous class, I mentioned that mBlock has a basic block coding setup. I'm going to talk about it now. As you can see, BizUnit has four major areas: request, statements, response, exception. It's easy to understand if you remember that I kept mentioning that I'm calling the AP. The user, client, requests a call to an AP endpoint or URL for some purposes. However, there are occasions when you must call with specific information. That's what the plus AP is now. Our computers, which do what they're told to do, don't know what value to add if they're simply called. That's why the AP can't work properly. Request is an area that defines what information the client should send together when requesting AP and how to communicate AP. The previously created Hello No Code School AP was simply an AP that returned the registered value, so no information was received upon request. However, since the plus AP requires two numbers to be entered, it configures a block to receive two numbers in the request body area. The hash map here is a data structure with keys and values. Call the document pair block in hash map, write Newman for the key, and add a null block to the value. The reason for putting null is not to register a set value in advance, but to put it as an empty value and set it so that the client can change the value directly. Since data type is a number, specify integer, num1 for explanation, and true for mandatory. Click the gear button on the hash map to add one more value item to create a block to receive num2. You can copy and paste blocks with Ctrl+Ctrl and change num1 to 2. If you open the tested after save and build the work up to here, the source we registered in the request body will appear. When you call an AP, you have to configure the value in that form and send it so that the AP can run properly. Statements contain the actual business logic that works when AP is called. There are three main pieces of logic that we need to implement here. First, logic to import request data as variables. Second, logic to check the values of two numbers in variables. Third, logic to add the two numbers that you've checked. To distinguish it well, I will make each logic by dividing it into helper's code section. Let's also put a description of each section in the comment block. First, to get request data and put it in the variable, we need to declare the variable and put the value in the variable, right? Declares the variable request data and connects the set to block. I'm going to use a new block here, which is the fetch block. This is a block that imports data from a specific set of blocks with an 8 into the hash map type, which is useful for importing and processing request data. If you enter the 8 of the request area into the fetch block, the operation number 1 is completed. The second is the block that extracts numbers from the variable request data. The extracted numbers should also be included in the variables, so let's start with the variable declaration. And this time, let's use the getHashMap variable block. This is a block that retrieves values from the hashmap data structure through the key. If the hashmap is superimposed, you can specify the exact key by adding a key with a gear. Now we're going to get the value of num1 as the key to the body in hashmap called request data. If you enter request data, request body, and num1, the value of num1 is included as a variable in Summa. You can change the value of the second number to num2 and work in the same way, right? Lastly, let's make a logic that adds two values. Declare the variable first to put the result. Gets the math operation block from math in block util, which runs the addition to the set to block, and connects the get variable block that reads the values of the variables summa and sum. Response is an area that defines the value to be returned when AP calls are successful. You've done it before, so I guess you're familiar with it. This time, we're going to return the sum of the two numbers as a result. So we connect the result of the variable that contains the sum of the two numbers with the get block. Let's test this AP After save and build, put the number to the request body. Once you click the Run button, the value will appear, and you can see that the AP runs properly. In the request body, what happens if you enter a value for another key, such as Strone, not Newman and num2, or if you enter a letter not a number? In this case, the computer does what it is told to do, resulting in an unexpected exception. That causes the AP to fail and the user to perceive it as a system error. An exception area exists for this occasion. You can organize the exceptions into several types and enter the logic to perform them separately if they apply. In this stage, you only need to know the concept and well deal with it in the future class. Finally, we give you a practical task in the hope that you will feel the sense of accomplishment you get when you actually implement it with your own hands. With what you learned today, make a calculator AP that adds, subtracts, multiplies, and outputs all the quotients and the rest. I hope you understand the API's request and response through this class. Thank you for taking your time.